In this example, we find the maximum or minimum value of a function on a closed bounded interval. Suppose the relative humidity in College Station on a given June day is 70%. According to meteorology models, the difference between the actual temperature, capital T, and the heat index, capital H, is approximately given by, we'll call it capital D, H minus T, is 0.0694 T squared minus 10.505 times T plus 399.05. Now, the record high and low temperatures for College Station in June are 107 and 53 degrees Fahrenheit, respectively. So at what temperature on this interval is the difference the smallest, and what is that difference? In mathematical terms, we want to minimize this function d on the domain t between 53 and 107 inclusive. So the steps to minimize a function on a closed bounded interval are as follows. First, we want to find the derivative of the function, which we'll use the diff command in Python. Second, we want to find the critical values. By solving where the derivative is equal to 0. So that means we will use the solve command. And then finally, substitute the appropriate critical values, namely the ones in the interval, and the endpoints into our function. So we're going to use the subs command in Python. So after loading the symbolic package into Python, we will define t as a symbolic variable using the symbols command, and define d as our expression, 0.0694 times t squared, remember to use 2 stars for the exponent, minus 10.505 times t, plus 399.05. As always, we follow these steps with the appropriate Python commands, looking up the details in the online help or previous videos whenever necessary. So we first find the derivative, which we will call d of d, the derivative of capital D, with respect to capital T. Second, we're going to define the variable crit vals for critical values by solving the derivative equal to 0 for t. And then we will print the critical values to check to see which one or ones are appropriate. So we obtain one critical value, and it is in the interval. Now for step 3, since we want to substitute all the values into the same function, we can create a list of these numbers, which I will call candidates. So our endpoints, 53. Our critical value, 75 point. Actually, we'll just go ahead and say crit vals, square bracket 0. That pulls the 0th element off of the list of solutions. Remember, Python always starts counting a list at 0. And this way we don't have to retype that whole long number. And then 107 is our last number. So now we're going to use list comprehension to compute them all at once. So y_vals is a list of numbers, square brackets, found by substituting into D for the variable t, the number I, for I in the list of candidates. So again, that is literally how we translate that line into plain English. So when we print y-vals, we see that the minimum difference is about 1.52 degrees. So we will put that in a print statement. So the minimum distance is y-vals, and this is the first number in the list because, again, we started with 0 and then 1. When the temperature is about 75.68 degrees. If we wanted to list it all out, we could again use the indexing. Of course, if you look at the endpoints, we see that this model is not realistic for the extreme values, but it will suffice for the purposes of our example here of how to find the maximum or minimum on a closed bounded interval.